All right, so today we're going to do some double angle properties. So the first page starts with some proofs. So for proofs, remember that you start on one side and you go to the other side. So I'm going to start on number 1 on the right-hand side. It definitely looks more challenging than the left-hand side. So I'm going to start by writing, well, 2 tan x all over 1 plus tan squared x. And even though we're starting on this side, you might want to look at the left-hand side and kind of just think to yourself, what is this going to look like? So sine of 2x is one of those double angles that we've been working on. So just off to the side, I'm going to say, well, sine of 2x, looking at your formula chart, you can say that that's equivalent to 2 sine x cosine x. So even though this isn't really part of my proof, it's kind of just me thinking about how I'm going to end up at sine of 2x. All right, so let's go back to what we're actually doing. I'm doing 2 tan x all over 1 plus tangent squared. Now, I know it's been a long time since we've done Pythagorean theorem, but hopefully this still rings the bell of Pythagorean theorem. And that was equal to secant squared. According to your formula chart, that's secant squared. And so I'm not going to change the top at all. That's still 2 tangent x. Well, for proof, sometimes it's easier if you think of things individually. And when things are only multiplied, which they are here, multiplied and divided, you can split them up so that you see each individual piece. So 2 is just 2 over 1. Tangent we'll rewrite as tangent. And now remember that you are writing these things equivalently. So what's really important is that if secant is on bottom, you need to continue writing secant on bottom. So I'm going to write times 1 over secant times another 1 over secant, because that's secant squared. And think about where we're trying to head. So you're trying to head to just sines and cosines. So let's change everything to sines and cosines. So 2 is 2 over 1. Tangent is sine over cosine. Now, secant. We know secant is the reciprocal of cosine. So if you see secant in the denominator, when you write it as a cosine, that'd have to be a cosine in the numerator. And so now we can do some crossing off. I see a cosine with a cosine, and I am indeed left with just 2 sine x times cosine x, which is exactly sine of 2x. So I do need to see this last step that you do, even though it kind of may seem repetitive, you wrote it up here. This was just you thinking. A proof is a very logical flow. This is equivalent to this, is equivalent to this, is equivalent to this, which is where we were trying to go. All right, let's do the next one. So the next one's actually very similar. We're even going to do that first step of kind of getting an idea of where we're headed before we do this. So even though I'm going to start on that right-hand side, just kind of off to the side, make a mental note or a physical note of what cosecant of 2x is. So cosecant of 2x, this is another double argument, but it's cosecant's double argument. And cosecant doesn't really have a double argument, but since cosecant is sine's reciprocal, we can rewrite that as 1 over sine of 2x. And then I see, okay, well, that's going to be 1 over 2 sine x cosine x. And that's how we're going to be able to get to the final answer. All right, so once again, we're going to start on that right-hand side. Let's rewrite that. Tangent x cosecant squared x all over 2. So this problem I'm going to do in a very similar way. I'm going to just, when this is all multiplication and division, we can just split that apart really, really easily. You can't do that if it's not multiplication and division, but since this is, I'll just say, well, that's tangent over 1 times cosecant over 1 times cosecant over 1, and then 2 on bottom is 1 over 2. All right, so tangent right here is sine over cosine. Cosecant, if cosecant is in the numerator, then when I rewrite that, it'd have to be sine, but in the denominator. So I'll just do that again right here. And then 1 over 2 I'm not going to change because there's nothing really to change for that. All right, so I can see that I have a sign on top that'll cancel with a sign on bottom. And that's all I can do for canceling. So what do you have left on top? Well, you have a 1 on top. And then on bottom, I want you to take a look at the bottom. On bottom, you have a cosine that's going to multiply a sine that's going to multiply a 2. And keep in mind, when you multiply, the order that you multiply doesn't matter. So what I mean by that is 2 times 3 is the same thing as 3 times 2. It doesn't matter how you multiply these things. So I'm just going to write it in the order that, we wrote it up here. Hopefully it's sounding familiar. 2 should be first, sine, and then cosine. This isn't really a necessary step, but it's just so that you can see it a little bit clearer. And so that does indeed make sine of 2x in the denominator. And if sine of 2x is in the denominator, then you could say, well, that's cosecant of 2x. All right, and let's do number 3. So number 3 is tangent of x is equal to 1 minus cosine of 2x over sine of 2x. So same thing, I'm going to start on the right-hand side. Now, just like we were doing before, think about what the other side actually is. Tangent of x. Well, that's the same thing we know as sine over cosine. Again, if you want to write that down, it's not really a real step or anything, but it's just good to know where you're headed. All right, so these guys, cosine of 2x and sine of 2x, are both double arguments. So that's something that you're going to have to keep in mind. So let's go ahead and write them as double arguments. So I've got 1 minus, and cosine of 2x is the one that has 3 different options. Your 3 different options are cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. So if you really pay attention to where we need to be, if you only want sine on top, the best option is to choose the option that only leaves you with a sine. So I'm going to write 1 minus 2 sine squared x. Now before I go on, what I've wrote is actually incorrectly written because I'm forgetting something. What I'm forgetting is that if you have 1 minus, this whole thing needs to get minus. So you also need to put this in parentheses because you're going to have to distribute that negative into both pieces. All right, and then sine of 2x, you only have the one option of 2 sine x cosine x. All right, so now I am going to go ahead and do that distribution. So I'm left with 1 minus 1 plus 2 sine squared x. So that was just me distributing into both things. And then 2 sine x cosine x. And at this point, you're actually done. We know 1 minus 1 is 0. 0 plus 2 sine squared is just 2 sine squared. Going fast because I'm getting excited. I see where I'm headed. And I'm done. Sine over cosine, which is tangent. All right, so find the exact value. We did this on Tuesday. It's your 5.6 notes. So just a quick refresher. Draw your quadrant, and that's quadrant 2 because it's from pi over 2 to pi. This is adjacent -6, hypotenuse 7. If you do Pythagorean theorem, you get root 13. And it wants us to find sine of 2x, then it wants us to find cosine of 2x, and then it wants us to find tangent of 2x. So sine of 2x, I'll do that one first. So you may want to pause this and see if you can do it yourself. I'm going to go kind of fast because this is not something new. So 2 sine x cosine x is equal to 2 over 1 root 13 over 7, negative 6 over 7 is negative 12 root 13 all over 49. All right, cosine of 2x, I explained when we did this that the best option for you to use is cosine squared x minus sine squared, and that's because it's going to get you a common denominator immediately. So that's negative 6 over 7 squared minus root 13 over 7 squared, which is 36 over 49 minus 13 over 49, which is 26 over 49. And then lastly, tangent of 2x. So tangent of 2x was the one that I actually did the full tangent, and then I said, well, remember that tangent is actually the same as sine over cosine, which makes it so much easier for you. So let's do it that way, sine of 2x over cosine of 2x. And the benefit to doing this is that you already have what sine's answer is. So I wrote it in red. I'll write it in red again, negative 12 root 13 over 49. And then 26 over 49. And since both things are divided by 49, I can just cross those off, and I'm left with negative 12 root 13 all over 26 as a final answer. All right. And I say final answer. All three of these were actually final answers. They asked for all three parts, so... All right, number 5, find the general solution. So we actually did a problem also similar to this on Tuesday. So our steps were to first match it, and then to draw the triangles, and to simplify. So this matches not really perfectly to anything, but if you divide both sides by 2, you get 2 sine x cosine x, and that equals negative 1/2. So now I can see this does indeed match perfectly to sine of 2x. So I can take inverse sine on both sides. So I get 2x equals inverse sine of negative 1/2. So what triangles do you draw to have a ratio of sine equal to negative 1 over 2? Well, that's negative pi over 6 and 7 pi over 6. So I get 2x equals negative pi over 6 plus or minus 2 pi n, and 2x equals 7 pi over 6 plus or minus 2 pi n. Now the goal is to get x completely by itself, so in order to do that I do need to divide by 2. So when you do divide the entire side. So you get x equals, and dividing by 2 is the same thing as multiplying times half. If you take something divided by 2, you're splitting it in half. So that's negative pi over 12 plus or minus pi n, and 7 pi over 12 plus or minus pi n. And that's it for your general solutions.